Hello everyone, and welcome to your video on geometric sequences. So you remember that we have an arithmetic sequence. And that would be a sequence like this: 10, 20, 30, 40, and so forth. And the way you know that it's an arithmetic sequence is because each time you are adding 10. Right? So you're adding an amount to the previous term, and you're always adding the same amount, right? So it's always plus 10, plus 10, plus 10, not plus 10, plus 2, plus 7.5. That would be not an arithmetic sequence. Okay, so another type of sequence is called a geometric sequence. And I'm going to give you a couple of examples of geometric sequences. So here's the first one. 2, 4, 8, 16, 32. So here what's happening is we're multiplying by 2, we're multiplying by 2, we're multiplying by 2, and we're multiplying by 2, right? So it is a geometric sequence because we are multiplying each term instead of adding each term, okay? Here's another geometric sequence. This will be, let me see, I think it's 135, right? So here we are multiplying by 3, we are multiplying by 3, we are multiplying by 3, okay? Again, because we're multiplying instead of adding, that's how you know it's a geometric sequence. Okay, it does get a little bit harder than this, although not much. This number right here that you're multiplying by, that number has a special name. That is called the common ratio. And it is denoted with the letter R, right, for ratio. And you will see this in the general term of a geometric sequence, which remember is just the basic formula for the geometric sequence. So let's talk about what the general term is. General term of a geometric, oops, here we go, sequence is a sub n equals a sub 1 times r to the n minus 1. And r here is your common ratio. So let's go back to this first equation right here, which is the 2, 4, 8, 16, 32. I'll write it down for you again. 2, 4, 8, 16, 32. Let's say that we wanted to calculate what this next number was, okay? We know that this is a sub 1, this is a sub 2, this is a sub 3, this is a sub 4, this is a sub 5, and so we're trying to find a sub 6. All right, so we are going to use our general term of a geometric sequence, which is a sub n equals a sub 1 times r to the n minus 1. So what would that be? Well, a sub n is what we're looking for. We're looking for a sub 6, actually. That's going to equal a sub 1, which is 2, times our r, which we already said was 2, right? Because we're multiplying each of these by 2. And then we're looking for n minus 1, so we're looking to the 5th, right? Because we're trying to find the 6th, so we do 6 minus 1 is 5. So that's going to be 2 times, first we have to do the 2 to the 5th. 2 to the 5th is 32. And then we would multiply that by 2, and we get 64. So our 6th term there is 64. And you should be able to look at that and see that that's the case. And you should be able to look to see what we did in the equation and see that that's the same thing that you would have done if you were writing the whole thing out. So, pretty straightforward when it's times 2, right? Gets a little bit harder when it's by, 5.16 and 5.16. But it's the same basic principle. You use this formula, which is your general term. You calculate R, which is called your common ratio. Now, let's talk about calculating the common ratio. Common ratio calculation. The best way to do this is to pick two numbers that are next to each other and divide them. So I could do 4 divided by 2. That's really a sub 2 divided by a sub 1, by the way, and that would give me 2. And then 8 divided by 4, that would be a sub 3 divided by a sub 2, which is also 2. Right? So to calculate the common ratio, you just take one term and you divide it by the other term. If it is a geometric sequence, then all of these common ratios will be the same because you're always multiplying by the same number in order to get to the next number. All right, that's pretty much all there is to geometric sequencing. We're going to do some homework now so that you can practice.